All right, so let's go to scikit-learn now. Scikit-learn, it's our problem, I guess, probably the first contact with any machine learning library for many of you. Now, what's cool about scikit-learn is that it's not the fastest, it's not the most advanced. You guys might have heard of TensorFlow and PyTorch and all these kinds of much faster and much more advanced machine learning libraries. But scikit-learn is easy and it's very straightforward, and you can basically get a model running in like 2 or 3 lines of code in 5 minutes, which is amazing in my opinion. So that's why we decided to have this in the course, because it's much easier to get started with and to get it working. And then of course, after you know machine learning, after you understand how it works, then you can move on to TensorFlow and things like that, because then you can do that in a nicer way. The problem with at least in my opinion, with teaching machine learning using TensorFlow, for example, is that TensorFlow is very intrusive. TensorFlow has its own way of doing things. So then you have to learn machine learning, but you also have to learn TensorFlow at the same time. So with scikit-learn, it's not the case. Scikit-learn is so easy and so straightforward that it doesn't really matter. It's not intrusive. So that's why we decided to teach scikit-learn in this course. And again, just as before, we import some stuff here. I won't really care too much about this. One thing that is interesting to know about this, let me see what's wrong here. Unfortunately, I have a problem with figure here. For some reason, there was a very nice figure here. I don't know why it's broken, but yeah. Let's see if we can actually open this somewhere else. By the way, this is a very nice tutorial if you guys want to take a look later. I will leave the link to this. No, it's not this one. Yeah, this is the figure that I want this to show. So what's the important part here? First of all, scikit-learn uses NumPy as its data, let's say, its underlying data model. So as I told you before, NumPy is kind of like a standard. Most, if not all, of Python data science libraries use, well, not all, yeah, TensorFlow doesn't, but most of Python data science libraries use NumPy as kind of like a standard data format. So everything is done using NumPy arrays most of the time. And with scikit-learn, the format of the array that you must have when you're using scikit-learn most of the time is this one. So it's the data set is basically an array that has the shape of the array, as we can see here. The size, it says size, but it's actually the shape. The shape of the array is expected to be a number of samples and number of features. So the samples are in the rows. So each row here is a sample, is like one individual element of your data. And the features are columns. So every column is a feature. So every column of every element determines the value of a feature for that specific element, okay? And usually you have another vector, which is the target one, where the labels are or the classes are. And that is usually just one vector with number of samples, because each sample usually only has one class or one label. So there's no need for more columns here. And this is used to train the models when you have labels, right? So always remember, samples are rows, features are columns, okay? So if you have like 10,000 elements and 10 features, what you're gonna have is an array that has 10,000 rows and 10 columns. So basically it's a rank 2 array with a shape of 10,000 and 10, okay? And this is the figure that should be here. For some reason it isn't, but it's written here basically. The data set have must be in the shape of numbers, number of samples, number of features. A rank 2 array with that shape. Okay. So for example, in this case, in this code here, I'm loading the handwritten digits that come built in scikit-learn. And then you can see, for example, the shape here is 1,797 with 64 features. What does that mean? That means that I have 1,797 digits, and each digit has 64 features. So again, 1,797 rows and 64 columns. Okay, and then for example, if I take the first sample, as you can see here, I just took first sample. I just took data 0. So that's the first sample, because that's the first row, and a row is the same as a sample. You can see here 64 different numbers which describe the 64 features that each sample must have. And in this case, the digits are grayscale pixels. And this one is actually the one that you're seeing here. So you can see here 0, 0, then 5, 13, 9, 1, 0, 0, and then wraps up here 0, 0, 13, 15, 10, and so on and so forth. I just made it square just for presentation purposes. Okay. One sample is always just one row like this. It's just that in this case, I just made it square in order to, because or else it would look horrible. I mean, you wouldn't be able to determine that this is actually a 0, because it would be just a string of pixels, which is how it is. But I just wanted to present it nicely, so I squared it like this in order to show it that it's actually a 0, right? And the label is also correct because it's a 0. So this is the input, okay? This is the data as it comes in to scikit-learn, is rows and columns. And below, we feed a simple support vector machine classifier using the features and the labels that we have. So basically, really, it's really incredibly simple to train a classifier by using this data that we have here. Let's go over the code a little bit slowly to see if I can make sure to express how easy it is to you. First of all, I instantiate the CLF here is like classifier. It's just a short for classifier. The classifier is in svm.svc. Now, usually I know, usually it's just svm, but in this case, it's just, don't get too attached by this. Just the way the scikit-learn decided to write the names of stuff. So svm is the module, and you can see that we imported it over here. So from scikit-learn, I import svm. So svm is now the module that I'm using. So from the module svm, I take the svc class, okay, and I instantiate it by giving a certain parameter here, gamma equals alto. Anyway, whatever. So every classifier will have its own parameters here. Like a KNN classifier will have the K parameter, and so on and so forth. So you instantiate the classifier here by saying, look, I want an SVM, and I want the gamma parameter of this SVM to be automatic. And that's it. The classifier is instantiated. Now, the next part is of course, to train this classifier, right? So first of all, so how am I going to do this? Just so we see how this works. I'm taking away one of the numbers. So we have 1,797. I'm going to take away one of them. So we end up with 1,796. And then I'm going to use these 1,796 to train the model. And then after the model is trained, I'm going to take back that one vector that I put away, and I'm going to try to predict the class of that using the classifier that I just trained. And let's see how it works. So first of all, I separate this into X train and Y train. So I'm saying, okay, the train data set here is digits.data. Data is the array from digits, okay? This is a NumPy array. And then I'm saying I want every row minus the last one, because that's what I want to do. I want to take all the rows minus the last one, and the last one is going to be isolated for now. And then I take digits.target. Target in this case is just the classes. Okay, so as we saw, I close that. So as we saw before, usually the labels are in a separate vector that is just number of samples and one column. That is the target vector that contains the classes or the labels. Okay, so I'm taking all the data samples minus one, all the class or the labels minus one, and then I fit the classifier here. And again, this couldn't be simpler. I'm just taking classifier.fit, and then I give the samples and the labels, and that's it. The classifier is trained, period. There's nothing else to be done. I hope you can see how easy and straightforward this is. The classifier is trained, okay? I mean, sometimes it's going to take a few minutes, I guess, depending on how much data you give it, but it's trained. Then we check the score on the training set itself. So basically I'm saying train score, CLF.score. And you can see that I'm giving, again, the X train and the Y train back, because when you ask for a score, you actually have to give it some data to be scored by the model. And in this case, since I want the training score, and I don't want to consider the guy that I removed from the data, I'm just giving the X train and Y train again. So I'm basically saying, give me this training score. And the training score is 1.0 here, as you can see down here in the results. And basically that means it's perfect. So this specific model here, this specific SVM using this specific parameter has been trained and is able to perfectly predict the class of every point. So it's probably overfitted, right? Because it's not common for a classifier to have perfect score. So it's probably overfitted. Let's try to check if it's overfitted or not. So I go and I take the test data now, X test and Y test, and basically this is what? This is the data minus one, which is the last data point, and the last class. So again, remember, I first took away the last data point and I trained the classifier using everything but the last one. And now what I'm doing is I'm actually taking the last one and I'm using it as a test data, not a trained data anymore. So I'm taking the last one here and the last target or last label here. And now I call CLF.predict. So considering that CLF is trained, right? Because I first instantiated it here, then I called fit, which fit in this case, scikit-learn has its own names for everything, but fit in this case means train. So considering that CLF is trained, I want to predict now. I want to predict the X test, right? So predict X test. And then, well, this is just I just put the test sample here so that you guys can see what it is. And the actual label is 8, okay? So that's the label that comes with the data is 8. Whether this is an 8 or not, it's, I guess, anyone can decide by itself, by yourselves. It's very hard to know whatever this is. But I guess the person who drew this was supposed to draw an 8. And as you can see, when I check with the predicted, it's actually predicted as a 5. So the test score is 0 because there's only one point, and that point has been wrongly classified. So the test score is actually 0. As you can see here, CLF score is X test, Y test. Now, this is quite interesting to see because we got a model that's perfect for the training data, but the first time we give it an external number, it fails. So it was perfect for the training, and it's perfectly wrong for the test data, right? So obviously that's not what you want when you train a classifier. And when you train a classifier, hopefully you want this to be general enough to be able to predict data that comes from outside of the training as good as, or at least as good as it was able to train the to predict the training class, because or else what's the point, right? You're just you just have a classifier that only works for the data that you have in your hands. That doesn't really happen. However, it's not a sad ending. Come on, man. Of course, I'm gonna fix this. So basically, of course, we don't want that, right? We want to have a more general model. And basically, what I'm doing here in this next cell is I'm trying this with a new parameter setting. And CLF's not okay. I didn't want this one actually. No. You see, it took a few seconds actually to train, so that's not super instant, but it's again like 2 seconds. So basically here what I'm doing is I'm manually setting some parameters of the classifier here. So I'm saying actually, you know, instead of auto, I want gamma to be 0.001 and the C parameter to be 100. And look, this is completely defined by the classifier itself, right? So the classifier itself has its own parameters. So that's what you're gonna use this here when you're like using some other model. And as you can see here, I chained a lot of method calls here like this, or just to show you that you can actually do this. Because every time you call a function like this, like classifier.set parameters, this returns the classifier itself. So I can then reuse this and call something else on it, like .fit, for example, .fit, and then I fit. So I change the parameters of the classifier here. Then I train it again by calling fit with the training data. And then again, I call again predict with the test data. And I just wanted to show you guys how you can do this thing. I guess this looks horrible. I think this is better. Yeah, this is better. So I just wanted to show you guys that you can do something like this. You can chain these methods one after the other. You don't have to do like CLF dot blah blah, CLF dot blah blah, CLF dot blah blah. You can do it like this because of this functional nature of how it works. And again, and then I just yeah, I guess you cannot do it like this then. I've been programming too many JavaScripts. You can do it some in other situations, but not in this one. Doesn't matter. What matters is that it's chained, right? And then there you go. Now we have a train score and a test score of 1. So basically, we are perfect both for the training and for the testing data. And I did it by setting up the parameters a little bit manually. And I mean, setting parameters, it's always a huge problem, and it's always manually done. And it's one of the most human parts of machine learning is actually setting parameters, because nobody really knows exactly what parameters to use. It depends a lot on your data set, on the characteristics of your data set, and so on. But anyway, every classifier has parameters, and you can set them like this. And as you remember, if you remember what we talked about before, the named parameters, you can see that I'm giving the names here. So the order here doesn't matter because I'm giving the names. So for example, if I do it like this, and if I put C first and then gamma second, it's gonna do exactly the same, because I'm explicitly saying C equals 100, gamma equals this, so the order doesn't matter at all, okay? And basically you've seen, so David, that's not a sad ending. Come on, now it's a happy ending. Now to actually finalize the lecture, finally, because I guess everyone is probably hungry, because I know I am. What I wanted to show you finally is that scikit-learn has a very, very how do you say, standardized API. Yeah, that's the word I wanted to find. There's a standardized API. So in the same way that I called classifier.fit.predict here, I could have called this with any of the classifiers that are available in the in scikit-learn. Okay. So for example, in this case, I'm writing basically the same code, but instead of using an SVM, I'm using a K-neighbors classifier, so a KNN classifier, right? And the API is basically the same. It's just I first instantiate the classifier. I give it a certain parameter like number of neighbors. In this case, I need to define number of neighbors because this is k and n, and this and by number of neighbors here, I guess they mean k. I don't know why they didn't use k. But anyway, number of neighbors, I'm defining it to be 3. So you have to define it because it's part of the what the classifier needs. It's a parameter that the classifier needs. And then you call fit and you call predict, and it's all the same. The API is always the same. You can basically switch between classifiers very easily. The workflow is always the same. You call it score, you call predict, you call fit, and everything is basically the same. You just have different instance of a different classifier here, right? I also did something here for cross-validation. I will just leave this for you guys to take a look at later. And also one thing that it's interesting here that I did was I took the predict probability here instead of actual predict, because for KNN I can't actually do this. Not all classifiers let me do this, but for KNN I can actually ask for the probability of every class. So instead of saying this guy is class this or class that, I can actually have different probabilities. So for example, in this case, when I tried the test data here, it gives me a 33% probability of being a 1 and 1, 2, 3, 4, 5, and sorry, 0, 1, 2, 3, 4. So it says there's a 33% probability of being a 1 and a 67% probability of being 4, I guess, for whatever reason. And the training score here is obviously not 1 like it was with the SVM. So the SVM did better. The KNN classifier did not do as good as the SVM, but it did very well. It's 98.88% right. So that's very good in any case, right? Just make sure that you understand here that actually I did some cross-validation here. So the length of the training set is now 1078 and the length of the testing set is 719. So it's not anymore like all but 1. I actually split into actual training and testing data sets here by using the function here, train test split, that comes from a scikit-learn model selection. So you can take a look at that later. But basically, I'm just splitting the data into training and testing in order to do cross-validation. Yeah. And then you can do k-fold cross-validation also by calling some specific functions from scikit-learn, which I will leave as an exercise for home. Yeah, final thing before I let you guys go. Sometimes it takes a long time to train a classifier, right? Especially if you're doing k-fold cross-validation, which I don't even know if you know what it is, because I don't know if you had it in the first lecture anyway. But at any rate, sometimes it takes a long time to train a classifier. It could take hours, depending on how much data you have and how slow the classifier is. So sometimes after you train it, after you've chosen the best classifier, you did parameter search, you did cross-validation, everything, and then, okay, you've arrived at the best classifier that you could have, you may not be willing to do it all over again next time you want to use your classifier. So maybe you're using your classifier many times a day, and you don't want to retrain your classifier every time because you got it. This classifier is good. I want to use it. So one thing that you can do is to use this module called Pickle that comes with Python. That's not like an external module. You have to import it, but it comes with Python. And you can use it to save your models to disk as like a binary file. And then afterwards, when you want to use it, you just load them from the disk. So for example, in this case, there's a lot of stuff here that I didn't introduce because it's too much. But basically, you can see that if you call pickle.dump, and then you can take this classifier, for example, the classifier SVM that was, I guess, not called that. So I should change that. Yeah. Anyway, it doesn't matter. So if you call like pickle.dump, then I'm dumping this classifier into the disk. into this file that I just defined here, like dot classifier SVM or something. And then if you can also load it from disk very easily just by doing pickle.load, and then you give a file to it. So if you use the same file that you used here to actually dump the classifier, then when you load it, you have a classifier, and it's exactly the same thing. It's the entire object, the entire Python object is entirely dumped to disk in its exact, perfectly preserved way. And then when you load it back, it's the exact same object that you had when you trained. So it's exact same classifier that you trained before. But of course, you don't have to go through the whole training process again, because you will see that as you go with the course, you're going to have to train a lot of models, and sometimes they're going to take hours and hours and hours. So it's very easy to know how to save them. And that is it, with 40 minutes over the time, which is quite a lot. I still have 21 persons in my Zoom, and that is crazy. So guys, thank you so much. David, I'm gonna answer you just a second. Guys, thank you so much for sticking with me here up until this point. I'm really sorry that I had to go over time. It's a lot of stuff, and I really need 3 hours for that. So that was it. All the notebooks will be put online in Moodle. I will probably clean them up a little bit before I put them up. The video will be also up at some point when I find out how to edit it, but certainly before like tomorrow at most. But anyway, I just want to thank you very much. 21 participants, great questions. That was really, 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 really good. Guys, so last question was from David. Sorry, but my internet was gone when you solved the problem with the 8 that was classified as a 5. I saw that you set manually some parameter and it was solved. But why does it actually work with those parameters? In other words, how do those parameters affect the trained classifier? Why aren't those parameters set by default in order to correctly work? David, setting parameters is always a very manual, very human thing in machine learning, because those parameters happen to be better for this data set, but they're not better for every data set. So that's why, for example, usually you have this gamma parameter to be set up as auto. Like this is actually the default. I just put it here because if I don't, then it gives me a warning, but this is actually the default. And it tries to find a good default that maybe works better in general. But every data set has its own characteristics, and setting up parameters is always a very manual human thing. And in this case, for the SVM and for this specific data set, these parameters just happened to work better. And this is something that you're gonna get like a feeling for as you go through the course. And to be able to understand exactly why a specific parameter affected a specific data set, that's something that you have to study, like each classifier individually, because each classifier works completely different than the other. It has different math foundations, and the parameters, they affect exactly these math foundations of the classifier. So in order to understand why a specific parameter affects a specific data set in a specific way, you have to understand how this parameter affects the math foundations of the classifier. And that is not very easy. So I don't have a good answer for you on that, unfortunately. But one thing that we're going to do in the next lecture is to do grid search or parameter search, which basically is we're gonna train like a lot of classifiers and all with different parameter settings, and then we're gonna choose the best one. So it's an empirical way of determining the best parameter. Okay. Yeah, mostly it is try and error. Yes. It's a hyperparameter. Yeah, Body said it's a hyperparameter because it's a parameter of the training, not of the model itself. So Usually, yeah, it's kind of like it's kind of try and error. Yes, most of the time, unless you have a very good understanding of the math foundations of the classifier, and then you understand exactly how each classifier or how each parameter affects the results. So that's a very much like an individual thing. Every parameter will have its own effect. So you can learn that. I mean, of course, if you become a specialist in machine learning, then maybe you learn that, and then you can predict, oh, for this data set, I need a certain parameter with a certain setting. But that's, like I said, it depends on each model and each parameter. Not sure if you, so Camila is asking, not sure if you showed how to load the data set provided by you into our Python program and use them during the lecture. Yes, it is all in the notebook itself. So if you go like, let me see here. If you go, for example, here, yeah, here's where I'm loading the data set. I went a little bit fast with this because I didn't have time, but you know, scikit-learn comes with some pre-packaged data sets, like toy data sets that you can play with, and this is one of them. This is not the full MNIST digits that we're used to having. Yeah.